Determine the largest angle in triangle ABC if blah blah blah. They give us all the sides. Alright, well, we've seen how you can adjust the cosine law so that it gives you an angle instead of a side, so we should be able to handle this. Let's draw a generic triangle here, and we'll fill in as much about it as we can. One of our sides is 14.7. We'll call that side little a, so the angle across from it is big A. One of the sides is 8.9. That's our B. The side is little b, and the angle across from it is big B. And one of our sides is 12.6. That side is little c, and the angle across from it is big C. So, where's our largest angle? The wrong way to do this is to find all three angles and then determine which one is the largest, but there's no need for that. A little known fact about triangles is that the biggest side in a triangle always has the biggest angle across from it, and the smallest side is always across from the smallest angle, and the middle side is always across from the middle angle. So, guaranteed, I promise, this side, the 14.7, is across from the biggest angle. A is the one we want. So, right out of the box, here's what the cosine law looks like. A squared is b squared plus c squared minus 2bc cosine A. Today they want us to find this angle, so it's actually A, capital A, that I want to isolate here. That is going to be, let's see, I'll take this term over to the left. This term goes to the right. I never did memorize this in the cosine form, I just have to work through this every time. Space in my head is at a premium, so if I can avoid memorizing something, I certainly will. Cosine A is b squared plus c squared minus a squared divided by 2bc. And we know all these things, so away we go. Cosine A is, it'll be 8.9 squared plus, side C is 12.6 squared, minus 14.7 squared, divided by 2 and 8.9 and 12.6. So I'll give my calculator a good pummeling here, and you can follow along if you like. 8.9 squared plus 12.6 squared minus 14.7 squared equals, divided by 2 and divided by 8.9 and also divided by 12.6. I get the cosine A is a rather skinny 0.09756. I'm not sure how many decimal places I need here, so we'll take a bunch. Not the answer, of course. We don't want cosine A, we want actual A, which you get by taking this cosine operator over to the other side, where it becomes, you can call it either inverse cosine or arc cosine. Either way, on the calculator, you're probably doing it by going second cos. And it should spit back an angle of, I got 84.4 degrees.